Okay, so we were just talking about what happens when we multiply complex numbers together. It turns out that you end up multiplying their moduli, their lengths, and adding their angles. And so, no, I said notationally, this can drive some people crazy. I guess I would like you to see this notation and get used to it, because this will, somewhere in some book, this will show up. You would do this. Z is equal to R1 e to the I theta 1, and W is equal to R2 e to the I theta 2, where R1 is equal to the modulus of Z, R2 is equal to the modulus of W. So then you have Z times W is equal to R1, R2 e to the I theta 1 plus theta 2. Okay, so I think we should do some examples to see what's going on here with this. And let's pick an easy number. Actually, remember when we did this before, here's 1, 2, 3, 4, 5, 6, 7, 8. Here's 1, 2, I, 2I, minus 1, minus 2, minus I, minus 2I. Remember when I was multiplying I and 1? So we know that I times 1 is obviously equal to I. And so here was 1. And if we look at vectors, I'm going to put little arrows on vectors because vectors tell us the direction. The end result ends up flipping this up here, and we go to I. Let's see that this is right. Let's see that this makes sense with what we've just been talking about. First, if Z is equal to 1, this is 1 plus 0I, how do you write this as R1 e to the I theta 1? Well, so the modulus of this, the modulus of Z is going to be 1 squared plus 0 squared square root. This is just 1 on a good day, so this is R1 is equal to 1. Now the question is, what is theta? Theta 1. And, well, hopefully you can see it's laying right on the ground. This is 0 radians. Here's pi over 2, of course. I suppose I'll put this in pi, 3 pi over 2, just to remind you guys. So this must be, Z is written as this, 1 times e to the I times 0. I times 0 is just 0. This is equal to 1. However, I'm going to leave it like this for the moment so you can actually see. Also, I'm going to point out something pretty interesting. How does it change? What happens if I do this, plus 2k pi? Well, is this going to change this at all? Basically, this is just spinning this around here. We'll get back to this more, but I just wanted you to think about it. W in this case is I, so W equals 0 plus I. That means that the modulus of I, this is the modulus of W, is going to be 0 squared plus, not I squared, this is plus 1 times I. B is 1 here, and a lot of people make that mistake, 1 squared square root. This is, of course, also 1. And what angle is theta at? Well, clearly, I is 90 degrees up. So W is going to be 1 times e to the I pi over 2. So now we claim that Z times W would be R1. Oops, and I was supposed to write this as R1 and theta 1. So this is R1 or R2 and theta 2 in this case. R2 is 1 and theta 2 equals pi over 2. R1 is 1 and theta 1 is 0 radians. So we said that when we multiply these, we should multiply the R1 and R2, which is 1 times 1 is 1, and then this would be 1 times e to the I, adding the angles 0 plus pi over 2. This is, of course, e to the I pi over 2. What does this mean? This is cosine pi over 2 plus I sine pi over 2. Cosine pi over 2 is 0, I sine pi over 2, sine pi over 2 is 1. This is equal to 0 plus I, which is, of course, exactly where we want it to go. So I think that is rather amazing that we know now if we multiply vectors in the complex plane, we are going to multiply their moduli, their lengths, basically, and then we're going to add the angles. I should probably actually look and see where we are in the book that I'm using here anyway to try and help you out. See, I really like complex plane, and it has so many great properties. Okay, I should probably be doing some. I should be doing some of your homework problems to be nice, okay, instead of doing all this. We will talk more about this polar form. You definitely need to know it. I'll start showing you now what you need to know for now, and we'll get going. So some of the homework problems are wonderfully easy. I suppose it's easy for me because I know what it is. If you don't think it's easy, I'm going to try and make it real easy. Okay, so, okay, this is really easy. Number doesn't matter. It says plot the number on the complex plane. So it says plot 3 plus 2i. Well, this shouldn't be hard for anybody. Well, I guess if it is, go back and review what we've done here and just keep thinking about it. Here's the y-I axis. So what do we got? 3, 1, 2, 3, 1, 2. This is 3, this is I, this is 2i. 3 plus 2i is here. We go up here. This is 3 plus 2i. And now to overteach you again, because I think these questions are just too easy. Better yet, how do you write? So this is z. First off, what is the modulus of z, or the norm of z? And this is going to be a squared plus b squared square root. This is 3 squared plus 2 squared square root. 9 plus 4, this is the square root of 13. And what does it mean? It's the length from here to here. And if I'm looking at this as a vector, I put a little arrow on there. And once again, what's going on? Vectors, remember vector addition? This is how it works. Here is the x component. Here is the vector. If we call this vector v, this is the vector 3 plus 0i, or just known as 3. If we call this 2i, right here, if we call this the vector w, this is 0 plus 2i. Remember vector addition, the parallelogram? Well, okay, so what were we talking about? If this was drawn right, here's a parallelogram. I'm adding these, so I'm just lifting this out of the plane. I'm taking the tail of this and putting it on what's called the head of this. And then what you do is you connect from here to here, and this is the vector v plus w. How would we write this in polar form? Well, so we know that r in this case, so I'll write this, z is r e to the I theta. This is the angle theta. How do we write this? Well, we already figured out r is the square root of 13. E to the I, what is theta? Well, so we know that the y part of this is 2 and the x part is 3, so this is arctangent of 2 divided by 3. Okay. We're going to have to break here in a second. 2 divided by 3, arctangent. This says it's 33.69 degrees, more or less. 33.69 degrees. This, if you do this, 33.69 degrees. This is never seen in the notation because this isn't correct. You have to really use radian measure. So that means we have to load a tape, but obviously you remember how to do this. 33.69 degrees times pi over 180. When we come back, I'll show you what it was.